So you should see my screen here. Attendance, did people sign in? Is everyone here? Okay, great. So let's end this, and I want to close this. We don't actually need a browser. As long as everybody has downloaded this, we don't even need that. So I'm actually going to close the browser. Well, maybe not completely, because we may need to consult the documentation. Okay, on the one hand, I'm going to have my project here. On the other hand, we're going to spend a few minutes here talking about stacks. So I want to tell you what stacks are. It's a collection. So what's a collection? What do we mean by a collection? And if you remember from the reading assignment a couple of weeks ago, I said there are a few overloaded senses of the word collection, but by a collection, when you simply lowercase collection like this, we mean simply a group of objects that are of related data types. So for example, just a bunch of integers that you put in the list. There are only a few operations that you need to carry out on these collections, whether it's a Java's built-in collection or the ones like the stack that we'll make today. You typically need to insert an item, remove an item from the collection, and iterate through the collection. We started talking about iteration last time. This time, what we'll do is we'll make our collection iterable, okay? We'll get back to iteration today. The only difference between the two kinds of the data structures that we'll discuss coming up, which are stacks and queues, is one simple thing. Where exactly you insert the item and from which part of the collection, whether it's from the start or from the end of the collection, you take the item out, you remove the item from the collection. That's the only difference. Remember in our SL list, what we had is we had like add first, add last, right? Remove first, remove last methods. In a stack, those methods are really called push and pop. What push and pop means, you want to put something in the stack, and think of the stack like dishes in a cafeteria. You stack dishes up, one on top of the other. So every time you put a dish in your collection, an item in your collection, you put it on top. And then when it's time to remove an item, you always remove it from the top. Okay, you don't just break this column of dishes to take some random dish from the stack, but rather you always remove the top element. And that operation is called pop. Okay, so now, we'll write this one in a second. So this one is normally called a LIFO discipline. So last in, first out. So the last item that goes in is the first that comes out. Okay, now queue, the only difference between a stack and a queue is where the item goes and which item comes out first. Okay, so queue is like a line in a cafeteria, right? So people line up or queue up, and the guy who comes in first is the first to leave the queue or the line. So that's called the first in, first out discipline, which is very different from what the stack does. We could implement a stack of strings, and but we already know about generics. So we will immediately make our stack generic. So whether we put strings in there or integers in there, it doesn't matter. So there are a few things you can do with stacks. You wouldn't be able to write a compiler, for example, which every computer science student should attempt once in a lifetime, writing their own compiler, but processing arithmetic expressions, for example. So in a homework assignment, you'll see how to balance parentheses in an expression using the stack data type. So that will be an assignment. Today, we'll have a couple of maybe slightly simpler clients, but still stack clients nevertheless. The idea, again, as always for us, is to separate interface with implementation and implementate. What do I mean by this? This may sound like, I may have said this, and I hope this is not the place where people tend to fall asleep. Separate interface and implementation, that kind of sound, what does it mean? Are people attaching concrete ideas behind these words, to separate interface and implementation? Can anyone explain what that means?
Interface doesn't actually tell you anything about how the operations are performed. It just tells you the return value and the name of the operation, whereas implementation is like the code that actually does it.
Yes, that's exactly right. The idea is the client has no idea how this data type is implemented and may have many implementations from which to choose. Okay, but regardless of which implementation the client chooses, the methods to call will still be the same. On the other hand, the implementation can't know what the client wants. Okay, it has to be uniform in its implementation of the method. It must promise the kind of method it will implement, and it will be the same no matter who calls it. So this has design advantages and creates modular and reusable libraries, which you can create. And I hope you're creating your own libraries too. You could, like with all this stuff, you can package all this code and have your own reusable libraries in the future. So here are the stacks. This is what we need to implement. So this is the stack API. this is how the clients of stacks communicate with the stack. Okay, stack of strings here, but it could be stack of generic items, could be integers. So you picture that these little squares here, these are elements of the stack. So you have really two main operations: push, put something on the stack, and pop something from the stack. Again, these are dishes in the cafeteria. And then you have all these methods like, is the stack empty? You can query your data structure. What's the size of the stack, and so on and so forth. Okay, so there's one client. Can you reverse? So maybe this is one of the assignments. You can do it with, how about reversing the elements of in a linked list? That's kind of a favorite interview question. I think I'll leave that one as an exercise. So I'll put that in the exercises. So I'm going to skip that slide then. Here's another one. Read a bunch of strings. Okay, like to-be file that you have downloaded right now. So you have this file. If you look at that file, so here's my terminal. Where am I? So I have this to-be text here inside my terminal, right? Okay, so if I look at to-be, this is what it looks like. This is my to-be text. This is this to-be text here. This to-be text. Oops. This to-be text here is this one. Okay, you can also view it, of course, here in this window. There's no need to do that. Okay, I want to give this file to my stack, and here's what it will do. Here's what we want our client at the end, if it works, to do. Every time I see a token, so these individual words like to, be, okay, these are tokens. So every time you see something like to, be, and so on, you put these guys on the stack. So by the time you reach that dash here, on the stack, you will have to, be, or not to, in that order. Once you meet this dash, you pop something from the stack. So what's the first thing that pops out of the stack?
Two.
Yeah, two. Well, actually, both answered two here. So this two pops out because that's the last guy that went in. So at this stage, I have to, be, or not. And then I add this be to the stack. So by the time I reach this dash here, what I have on the stack is to, be, or not be. That two is gone. Then I pop two of them. Okay, every time I see a dash, okay, my code says if I see a dash, here's the line of the code that says if I see a dash, just pop this element and print the guy. This also prints the guy that was popped. Okay, so right now at this stage, by the time I reach this dash, I have to, be, or not be, and then I take the be off. Then I take the not off when I reach this dash. So I have to, be, or. Then I add this that. So at this stage, I have to, be, or that. Then I pop three of them. So I pop that, that, that. So three of them, that, and that. And then I add is. So do people get the idea? So every time you see a dash, you want to pop the last element from the list and see what's left in it. Okay, so now let's get back to what we have. Now, let me tell you that the easiest way, the absolute like three-liner of a way to implement the stack is to just use the SL list that we have. So because SL list is nothing, so the stack is nothing but a restricted version of a singly linked list, you can do the following. So let's start from the easiest one, the stack inheritance, which will be actually our least preferred way. So notice what we have. So I'm opening up my ID here. Okay, so do people see the ID here? Actually, let's not do that. First, let me show you the structure. So I've opened stack inheritance here. So I only have two methods, push and pop, as the slides said. Okay, so now I just want to implement push. What do? Notice what my class signature says. That stack inheritance class this is my stack. This class, first of all, it's a generic class, and it extends SL list. So every method that's available in my SL list, let's open that up. And the structure of that one is, it has a bunch of methods like remove first, remove last, remove first, and so on, add last, and so on. So I want to use those methods. So here's what I'm going to do. My push operation, so what's going to be my push operation? So can anybody help me out? Like, what's my push operation?
It's just your add last.
Yeah, it's just, well, actually, you know what? That's a good idea, and you should try it, but we're going to do it add first. So our push operation is going to be add first, okay? Add first, and I'm going to add this element, okay? So, but yeah, you could, I understand why you may have said add last, but maybe we'll return to that point later. So let's do push, let it be add first. And then pop operation, what would it be?
Remove first.
Yes, yes, exactly. Remove first, right? Remove first, okay? And that's, okay, so this is not gonna work. So I'm not gonna remove null. And the reason I have an error here is because this remove first operation, let's take a look what it does inside SL list. If you remember from last time, remove first returns this item, the removed item, okay? Removes from the list and also returns it. Okay, and in our stack inherit, in our stack, we want to remove this and also return the guy that we removed so that the error goes away, right? So we're simply using remove first here, okay? And add first and remove first. That's it. We now have a stack. Okay, so let's test it for a second. So here I am creating a stack of this. That's it. You have the stack. Now let's add like, check if this stack is empty. How do you do this? Can I just simply override? How about this? You simply return SL lists is empty method. If I'm using SL list in the background. So this will work. This code will work. Okay, so like when you upload it, if you're missing this method, it's okay. So, but we'll get to implement in other versions. But anyway, let's test it. So I have this stack. Okay, so stack. Notice the problem with inheritance. The client is still aware. This is why we don't prefer to use, although this is super short. As a software engineer, you wouldn't write your stack class that way. Okay, I'll return to that point later. One of the reasons is that I have a bunch of methods available here on my stack that shouldn't be there. That's why that's one of the reasons why people are discouraged to use Java library, Java's built-in stack class. That's because it's what's called a fat implementation. I'll get back to those later, which means simply that it has a lot more methods than it should have. A stack is something where you can push something and pop something out of it. You shouldn't be able to access middle elements or anything else, like all these bunch of other methods that are available in the libraries, right? As a stack, if you're using a stack, you don't need access to them. So it seems like it's a good idea to have more than you need, but it turns out in practice that this is more of a curse than a boon. Okay, but anyway, let's get back. So let's push. So we need to push something to the stack. So it's a stack of integers, like I'm pushing some element there. By the way, can I print this stack? What happens? Okay, so let's put a couple of things. Stack push 6. Let's push 6. Can I print the stack? Can I print the stack? So let's see what happens if I do print the stack. Okay, how did I know to print the stack? Right? Notice that that's because all of these methods, so my SL list has this 2-string representation here at the bottom that prints the stack the way we printed last time. Now, in a stack, you may want to override this so that there's no null printed on your stack and so on and so forth. But that's a different issue. Okay, but you're able to print it because you're accessing the superclass 2-string method here. Okay. Okay, so let's push one more. Push. All right, let's see. Push like 1, and you can, if you'd like, print this again. So that's going to be this one, 168, I have on the stack. How about popping an element? Now I want to stack, remove element. So which one is going to be popped? Notice I have more methods than I really need. I just need push and pop. This guy even returns the element. I can print this guy if I want to, or I can just print the stack itself at this stage. So let's see what we have. So notice we had 168, and then I popped the element and the first guy came out, 1. So now I'm left with 6 and 8 on the stack, and so on and so forth. So you get the idea. So any questions about this? So this should work, right? We have just like 2 lines of code, and this works just fine. Now here's another test. Okay, let me uncomment this and tell you what's in it. I'm creating another stack. Let's call it stack 1. And now I'm reading a file. Now before, when you read the file, you had all this complex code just to read, like scanner and scanner next, blah, blah, blah. You had just 5 lines of code just to read a bunch of words from a file. No longer in this class. You'll use this class called in, okay? Simply place your file, your text file. So later you'll have large, maybe, files that contain integers to process them for one reason or another. So you just simply say in and just read it, okay? And now once you read it, okay, so now while there is still something coming in from this stream, while there's still something in 2B, and in 2B I have these tokens, which are words coming in. So I'm going to read each string like a word, like to or be or whatever comes in. And if it's not a dash, the token that I just read, I'm going to put it on the stack. So I'm pushing to, B, and so as long as I'm not reading the dash. However, so notice, okay, so this happens, you can see what's happening. As long as there's still something on my stack, that there's like, there are words in it like to, B, as long as the stack is not empty, when I see a dash, so this else if happens when I actually see the dash, I'm popping an item from the stack. When I saw the dash, just popped it, okay, and printed the popped item. Okay, so this is the popped item. And I keep processing these elements that come in. And then finally, I'm looking at what's left on the stack, and I'm also printing the stack. So let's run this and see what happens. Okay, so, okay, first of all, let me just comment this initial test. So we're going to start from here. So stack 1 is what's going to be created. So let's run this. And if you run this, you should get this output. Okay, so if you examine this next to the 2B file, notice what happened. So I had these guys, then I popped this, so I was left with that. Then B went on there, so now I had 2B or not B. Then I popped the top 2, so I was left with 2B or that. And then that or B was popped off, so I was left with 2 and is. Is went as the first element. So now this is exactly, so these were the items that were popped. Okay, and this is what's left on the stack, right? Do people see this? Do people see how stacks operate, right? Okay, so now we have a working version of the stack, but now after all this work, although it wasn't too much work, now I'm going to tell you that we don't want to write our stacks this way, okay? So now I'll say, why? I have a stack, I can use this. No, okay? So now let's take a look at composition. If you ask any software developer, they'll tell the favor composition over inheritance. And you'll say like, okay, that makes sense. But why? Okay, all right. So we'll just follow that dictum blindly, and we'll actually favor composition over inheritance. So now how would you do, first of all, what do I mean by composition versus inheritance? We just implemented a stack using inheritance. By the way, today we're just using linked list implementations only. So what's the difference? Inheritance versus composition. So the difference is has a difference. So what exactly is the difference? So this guy that we already have, this guy with inheritance, just simply reuse the methods from the superclass. Just simply reuse the methods in the super, just renamed them essentially. Okay, it has access to all those methods. With composition, I'm creating an instance of a class of the singly linked list class, which I give a name to it. I call it stack list. Okay, could have called anything, but I have this as a field. Okay, this is has a relationship between stack composition and SL list. Stack composition class has as one of its fields, it's a has a relationship, has as one of its fields a list, a singly linked list. And then in order to be a stack, this guy stack composition wants to be a stack, that is it wants to have this push and pop methods, it will still reuse the methods that are available there, but slightly differently. So how would it push an element? It will take its field, which I haven't yet initialized. This one will produce an error, but we'll fix it in a second. So I'm going to take my instance of stack list, and on that list, I'm going to call add first, right? And I'm going to add this element or item, if you want to call it, doesn't matter. So I'm taking my instance of a stack list and I'm using add first and that. Now notice what I'm doing also. I'm making this guy private. The clients of stack composition have no idea, have no access, first of all, to the stack list because it's made private, and have no idea what methods are available in stack list, in the SL list. They don't know whether, how this linked list is implemented or anything. I can't call those methods at all, and therefore can't make too many mistakes. Okay, so here, what I'd like to do in the constructor, I want to simply create an instance of a singly linked list class and assign to my stack list, okay, that new list that I'll create. And because this is my, I want to make it of the same type, okay, so I put this E there, or item that we put last time, E, just element, generic element. That's it. So I've created simply, when I created this class, the stack composition, I now have an instance of my singly linked list class, which clients of stack composition have no knowledge of, shouldn't know about, shouldn't know its methods. They just simply want to call push and pop. That's all there is. Okay, so push is clear. We just add the first element to this list, and that's all there is to it. So how about, what do we do with the pop? So help me out this. So return null, we're going to have to change this line. Okay, so we're going to be returning the element that we remove from the singly linked list, but from somewhere. Okay, so we're just going to have stack list, remove first as before, right? So remove first is what we're doing, but we actually also want to return this. So I can simply say it in one line, return, remove first. Okay, just return, remove first. That's it. One liner. I have a pop method. That's all there is. The isEmpty is already implemented. Return the stack list isEmpty method. Okay, if I want to print this time it's kind of a cop-out, but you should really override this. So you print it like a stack, really, so that you don't have these like arrows and all of that. So it would be nice to override it, but if you don't, that's fine. Size, do I want to know the size of the stack? Well, just return the stack list size and so on and so forth. That's it. That's it. That's all there is to it. All right, so let's add something to the stack. Stack, push. So I need to push like an integer. I don't know, 8 were pushed. Okay, stack, again, stack, push, I don't know, 77 were pushed and so on. Can we print the stack? Yes, we can print the stack. Let's see what it looks like. 77 and 8. How about let's pop an element from the stack? Stack, I want to pop something. You'll notice now the methods that I see here as I'm coding this, just only a few, just exactly the ones that are available in the stack composition class. I don't need the access to SL list methods. Those should be private. I'm just manipulating the stack. That's the data structure that I want. That's the ADT that I want, pop, okay? Actually, can I print the popped element? Yes, you can. Okay, the popped element. Okay, so here's your popped element. That's the one that you just popped, right? This is the popped element. And then you can print that the stack now is, and then you just print the stack. Let's see what that does. Okay, so the popped element is 77. So you decided to pop 77. That is, remove the first element from the top of the stack. So the first one was the top. Now, one of you suggested, why add last? That was a natural suggestion. I could be adding this stuff at the very end, but why am I not doing this? I will ask you at the end of the class. Why did I do first? Or maybe I should ask you after we cover big O. But we'll return to many of the things that we've already covered after we do big O. So 77 is what I'm removing. 77. Now the stack has not just one element in it. So if I print the size of the stack, okay, stack size, okay, simply print the size without adding any words, I'll get 1 here. And finally, if I pop another element without saving it away or printing, and then print again this guy, okay, then I should have 0. Now it's 0, and so on. And the way this is coded now, what happens if I pop it again from an empty stack? What should the client do? Then it's up to you as a designer to decide how to exit, gracefully, not so gracefully, throw an exception, whatever. Now, let's say the way this is done, it throws an exception and exits, which is a reasonable way of doing it. If I pop now from an empty stack, and if I try to print my stack, right? Stack or stack size, whatever, stack size. Now let's see what happens. Exception is thrown. That empty list is the same exception that we did last time. It comes from this private field here, which is of type SL list. That's where it is. Okay, so I think people get an idea of this. So we have, as of right now, you have two versions of the stack. Okay, well, we haven't used them really in something useful. Oh, by the way, let's make sure that this guy also works in this version exactly the same way as before. Notice that the client code, this is the client code. The client is now using stack composition, a different version of the stack. How it's implemented doesn't matter, but notice when I copy pasted this code, I didn't change anything in the way I called the methods. I still have push, I still have pop. Okay, I just have a different implementation of the stack, which is signified by the name of this class. And when I run this guy, and I do want to remove this exception here. And actually, I want to remove all of that. Okay, so I'll let you do your own test cases. I'm going to go with mine here from the file. So if I run this, I get exactly the same output. I'm printing the guys that I'm popping from to be or not to be file. And then once I'm done, I have two left on the stack, and I'm printing the stack at the end, the way SL list printed it before. Okay, so that's exactly the same output that you saw with stack inheritance. So that's called stack composition. That's a stack. Finally, we'll get to, so these are two ways. These are two ways of implementing stacks. We'll actually have four ways, but today we'll complete three. Okay, the other is by its nature different. The other one, the fourth one, will use an array in the background. Today's implementations all use singly linked lists. Okay. All right, so let's now let me tell you something about this one. So now we'll be filling in this one. This will be the class that we'll use throughout the rest of the semester. This one, again, at the end of the day, it should print the same thing. When you make this work right now, if you uncomment these lines and if you run it, you will fall into an infinite loop. So for now, don't yet uncomment it. Once we're done, okay, we'll start testing it from here. Okay, so maybe I should split this and have both sides visible so you can see. So here's the test code is going to be here on the left side. And here I'm going to be implementing all these methods on the left side. And on the bottom, we'll see the results as we run them. Okay, so here's what we're, notice the difference. Oh, by the way, let me tell you, here's one thing that will not work in the previous versions of my stack. If I try to use, and this is the same with SL list, with the singly linked list class, try to use for each loop, which you could easily do with Java's arrays and so on and so forth. If I try to do this for each string on my stack or stack one, I'll get an error. This for each, if I wanted to just simply print each string in my stack, let's say this way from the client, like this way, which is one of those short ways of printing things. By the way, another way, this complete aside, is using lambda expressions, which I recommend people learn about, but that's maybe at the end of the class. But simply by printing it this way, okay, so for each element in it, it just doesn't do it for me. And we want to fix that. We want the clients of our stacks. That's one of our goals. We want the clients of our stacks to be able to use this for each construct easily. We want them to be able to write this code just as you do with like Java's array lists, right? Now, let's see what it tells me. Okay, it tells me that for each is not applicable to stack inheritance, to my class, stack inheritance. If I did it with stack composition, I would get exactly the same error. So why is it not applicable? That's because my stacks are not iterable. They're not iterable objects. So the final version of the stack that we'll make today, so let me remove this, this just doesn't work, okay? But you can make this iterable. So we'll make our stack class iterable this time. And the way to do it, the way for the clients for each code to work is for you to make your classes iterable. So make them implement iterable interface, which makes your stack class iterable, okay? So that you already have in the starter code. Okay, so on the right side, by the way, this is the client. Now, notice that I am, instead of doing explicit inheritance from my SL list or anything else, I'm coding the methods myself in my stack. So it will just only implement the iterable. It does not have to extend the SL list or anything else. And now, because you've practiced with singly linked lists, you'll help me implement this in a minute. First of all, we have the simplest helper class possible. Just node, a generic, just simply nodes. These are linked list nodes as before, okay? Initialize an empty stack. Make sure, so notice now we're simplifying this. Why am I not using SL list? Notice I don't have the last. Okay, so remind me just to make sure we're on the, so in the SL list, what was the purpose of this last? Okay, so notice that I declared two nodes, first and last. Do people remember what the point of all these guys was? Like the purpose in life as we know it of first and last, what did they do? And why did we have them there? Actually, it shouldn't be quite clear why do I need both of them. I mean, you could easily get away with just one of them and just not deal with just last here. We'll have less code if you don't maintain the pointer to the last element. For some reason, we included it. That should not be quite clear. Why did we include it? But you should be asking me. But I'll only reply maybe in a couple of, well, next time. But anyway, we had first and last. Those two pointers always pointed to the first and the last elements of the singly linked list. That was the point of those guys. Okay, in my stack here that I'm implementing right now, I only have first. So notice, as you remember from stack inheritance and stack composition, my push and pops are add first and remove first, right? So I don't care about the last pointer here. I'm making this code as simple as I can and as efficient as I can also, because it will do these operations in constant time. This will be the stack that you will use. You want to make it efficient. So I just have first. When I initialize my stack, it's going to have its first pointing to null, and the number of elements in the stack, my n, is going to be null, 0. Now, this one is already implemented. When it's the stack empty is when first points to null. I could just as well have returned size equals 0. If the size equals 0, then that's it. There's nothing in the stack. Could have done it that way, but either way is fine. Size returns that. Now I'm implementing push. How do I implement push? How do I implement push? So how do I implement the push? This is pop. Do I have push? Hold on a second. Pop, push. How do I implement push? Okay, so here's my node class. This one is a node of strings, but generic node. Let's say I have strings like or b2. And I want to add the first element to this linked list. In this case, the stack. How do I do this? I introduce a new node. First, we'll point to this new node, and then I'll make sure that this node is linked to whatever the old first was. But for me to be able to link it to whatever the old first was, I must save it away at the very top here. Okay? So you remember, people remember this? This is the insertion at the front of the list. So you'll get more practice with these things, like in the middle and blah, blah, blah. So this is kind of tricky code. Now, this one is not that tricky, but linked list code can get quite tricky, actually. You can easily make mistakes with that. So I'll add some exercises to the next lab to make sure you get some practice with those. But anyway, we don't need that. OK, so now I'm going to implement this push here. So how am I doing? How am I going to do this? Okay, so sorry, one more time, please.
You want to create an empty node first?
Yeah, okay, let's do that. That's, well, empty, okay.
I suppose you do it that way as well.
Okay, all right, let's keep that one. I could have, yes, you're correct. So let's create a new node. This is what you suggested, and I should have done it that way, but that's fine. So let's follow your suggestion. I'd rather do that. And I'm creating this new item, right? Make it item or item. Okay, so I'm doing an item here. Could have done E, whatever you want to name it. Since it's item, it's item. So we've created that. Just as this, so I'm following your suggestions and the slides too, this picture, right? I'm implementing this picture. Okay, so I have this guy, and then what it is. So I'm going to say that first item is going to be this item, right? Is that, were you suggesting this, or am I just typing this on my own?
Yeah, that's what I would do next.
You were going to, right?
That's already what I have.
Oh, okay. So first, how about first next is going to be old first, right?
Yep.
Okay, and then increment it. That's it. That's how we added. What I just did is I just translated this picture here, this picture, into code. Okay, great. We have push. Let's do pop. That's going to be also not complicated. So where's pop here? Here's pop. How do I remove? Again, our pop is going to be removing the first element. And we have no need for the last point or any of that, just first. So I'm going to save the item first, whatever was in first. And then my first node is going to point to first's next, right? Whatever first next was, which was B. My first is now going to point to that B. And then, of course, pop returns the item. Okay. Maybe you later want to write a version of this pop that doesn't remove the item. It's usually called peek. Okay. So there's pop, there's peek. These are standard names for these methods. So peek just looks at what's at the top of the stack without removing it, and pop looks at it and removes it. Removes and returns it at the same time. This time we are doing this runtime exception here, checked exception here, called no such element exception. That comes from Java util, so might as well use that one. We didn't use that one in our SL list, but let's use this as more appropriate. And it also prints the message, why is it just threw this exception? It threw this exception because I couldn't pop anything from an empty stack, and I told it there was empty. That is Stack Underflow sometimes. Stack Overflow, apart from that popular website where you get answers to your questions, is when you run out of memory. The stack's like you've pushed too much stuff on the stack. Okay, that's Stack Overflow. Okay, anyway, is empty. So here we have it. So what I need to do, so help me out. So did I say item, right? So I want to save, did we say in the picture, we said we want to save the first item. Okay, we want to save that. And of course, that we want to assign it to this new item. Okay, okay. And then once we have that, okay, so okay, so help me out. So here's the picture. Here's the picture. I've just done that. This top piece, I've just done here. I've just saved the item. The slide says string here, but you know, we're already going generic. So I've saved the top item. I want to delete the first node now, right? And then return this item that I've just saved up. So if I say at the bottom, if I say, okay, return item, I'll be fine. But now I have to delete the first node also. So how do I delete the first node? You simply assign first to whatever first next was pointing to before. Just reassign, repoint it. Does that make sense? So all I'm saying here is that first is going to be first next. And there's something that the slide doesn't say, but you should be stopping me right now before I return the item. I need one more line. I just popped something and I want to maintain, and again, I'm using the terminology, maintain the invariant that, what is the invariant? That the size of the list is always correct. So that every time a client wants to know the size of this list, of this stack, I, as a designer of the stack class, must promise the client that we'll always get the correct answer about the size of the list. It will always be correct. How do I do this? Well, a bunch of tests, of course, but when I pop the item, I shouldn't forget to decrement my variable, my private variable n, which, you know, on which the size depends. N is the number of elements in the stack. Okay, so that's my pop. Okay, that's great. Now we have the peek method here. It doesn't remove anything. It's already implemented. Peek simply says, if the stack is not empty, just take a peek at what the first item is. What would be the item that I'll be popping next if I have to pop something? Just simply so that the client can know what the item is that's about to be popped. The toString is a little better. Now we're implementing our new toString so that it doesn't print those arrows. We don't need those arrows and the null and all of that in the string representation. So we'll use this version, again, a simple version. And now we'll finally come to the crux of the matter of today. First of all, let's test what we have. Is on the right side, I have my stack push. This time it's a stack of, looks like strings, right? So let's get Zeno in there. Zeno, and maybe we should, how should we put, like ICO there? And let's just print that. Let's just print the stack. Okay, see what we have. Oh, what am I getting? What is that? What is that? Out of memory exception. Why am I doing that? Okay, what's going on here? I'm creating, did I make a mistake? Push, push, push. That
It's
is
failing
weird.
on the two-string method.
What is it?
It's failing at the two-string method.
Oh, where? Okay, so should I get to the, let's take a look where it's failing here. Here it's failing. Okay, now should we, let me take a quick look. I won't spend, what is it?
Is it because we haven't implemented arable yet and your two-string method has a for each loop?
No, it shouldn't do it because of that. So, sorry, say one more time, please. Maybe I'm missing something.
So the reason why so in 64 of your stack.java file on the right, it has a for each loop. And
oh, it does. Oh, thank you. Thank you. If I didn't comment that on line, where? 64?
yeah, on the one on the right, it has a for each loop.
Oh, yeah, yes. Okay. All right. So, okay. So, yes. Okay. So for now, yeah. So for each right now should not work. Okay. So that's a good start. So if I do for each here in this stack, notice what's, you know what, you're absolutely correct. The reason is that we're making this iterable and our for each thinks that it's going to work. Okay. So if I didn't make this iterable right now, okay, my for each wouldn't work. My for each wouldn't work here. See what's happening? My for each isn't going to work. Now at line 64, as you mentioned, this for each isn't going to work either. So if I comment this out for 1 second, shouldn't be doing this, but let me just do it this way. Now, right now, if I run this, okay, this should work, but it will, of course, print the memory address where the stack is stored. It doesn't give me a nice string representation of it. So now, as you've just suggested, we have to make this work. We have to make this for each work. So when I write down something like for each, right, I want this guy to work. Well, not string args, but rather stack in my stack. I don't want this error. So now that's what we're fixing next, okay? And then our two-string method will work, okay? So that was a great catch, okay? I forgot to do that. Now, first let's make the errors go away by making this guy implement iterable. Okay, now the errors go away, but my code doesn't work because I haven't made this class really iterable. Now, if you remember from last time, what does it mean for a class to be iterable? So it means the following. This class, stack class, let's get to the structure. My stack class here is iterable because it has this method iterator. So this guy tells me that this my class that I'm writing right now is iterable. And for it to be iterable, it must have this method iterator. That's what it means for a class to be iterable, because that's what the iterable interface specifies. So now I have to write this object myself. So I'm saying in my method that I'm returning something I'm calling linked iterator. You could call it anything you'd like, but as long as it's an iterator, as long as it's an iterator. Okay, what does it mean for a class to be an iterator, not iterable, but an iterator? It must implement, this is a different interface. I have an iterator interface and I have iterable interface. Again, iterable interface says it has a method that returns an iterator, and that iterator, this linked iterator, is again a nested inner class here, making my class that I'm writing an iterator. Now I go to the specification of this interface. If I go to its documentation, it will tell me, and I'm not going to go to the website now because we're running out of time, but it will tell me, if you look at it, that I must have these two methods. Well, actually three, but one is optional, so we're never implementing this. It must have this method, hasNext and next. Notice how similar that sounds to the scanner that you've used, but these are different methods. So next method should be there and hasNext method should be there. That's what the for each construct needs in order to iterate through this collection. That would make this collection iterable. First of all, inside my class, I have a constructor. Okay, this list iterator constructor of this class, this is a nested class. It creates a node. This current, where does this node, where does this come from? Well, this is an inner class. That's the beauty of using the inner class, these inner classes. This first is a reference to the outer class's first field called first. So this inner class has access to first. So I don't have to complicate my code by writing separate classes. It knows about first. So now it's creating inside itself some guy called, again, this is a node type reference, called current. This current will go through the elements in a minute. We'll go through the elements of this collection, of the stack collection. So here's how it will do it. What does it mean for in my collection to have a next element? So let's try to do that. What does it mean to have has next? If this current's next, if a current itself is not null, then I have, if current itself is not null, okay, then there is a next element in my list. So for example, take the edge case where my current is first. Okay, I initialize this at first. If there's nothing currently in my stack, this is going to be null. And has next is going to return false because this expression here evaluates to false, right? If current is null, null is not null is false. So that will return false. Anyway, then you have next method. So these are the two methods that we need to implement. Next one, first of all, if has next tells me that there's nothing, there's no next element. If this method tells me there's no next element, I'm going to throw an exception. But otherwise, what I'm going to create, let's see, and I need an item here. You'll see what I mean in a second. So item is going to be current, the current item. This is the guy that I want to return. Is going to be current item. This is, so I'll be returning this. Return item. This item I'll be returning from this method. This is a local variable here. But I'm setting current to current next. That's it. Current next. That's my next method. That gets me the next element in this collection. And now my errors go away. And now the magic happens. And this is why we needed to make it iterable, because first of all, my toString method will work if I uncomment it here. Well, I've already uncommented. This will work. But also in my client code, if I say something like for something in my stack, if I put something there, I should be able to actually print this, each one on the individual line. So now my output should be much better than this. So now if I do this, then I get my ICO and Zeno, and I've also printed ICO and Zeno from here as well, right? So if I remove this guy, and if I print it, I allow the client to print this the way the client likes, it's going to print it on its own individual line, or I can have my string representation of my stack here. That would be nice. But anyway, how about let's pop something? Let's stack, let's pop the first element. So let's get ICO out of there. So now this guy should print just Zeno, okay? So now I have just Zeno, okay? So it's working. So if I pop it one more time, so that my stack is empty, what am I going to print? I'm going to print nothing, because that's the way my toString method is. And if I pop something from an empty one, that this time I should get an exception. So if I run this, now I get an exception. This is working. This is amazing. This is nice. Okay, so now let's delete that. So you see how for each works. For each works. Now let's finally, we have a nice, so this is the stack. That's your stack now, okay? A linked list implementation of a stack. Make sure this works nice. This is the stack that you will be using in every time you need a stack, like when we get to graphs, you'll see in graph processing, you will use stacks and queues. You will use this stack, not somebody else's stack that somebody else wrote, or even Java library stack, which is what we'll call a fat implementation later. You'll use your own lean implementation. You have all the methods you need and only those methods, nothing else. That's what stack should be. What you have right now is what a stack is. Anyway, let's check in our test case here. Let's get rid of ICOs and so on. So in addition, so let's uncomment this. So now this guy should work, okay? So you guys are doing great. You helped me out actually today quite a bit because, okay, so.
You need to uncomment those two, you need to recomment those 2 lines there in the middle.
Which ones?
Well, if you wanted to run that code, you were missing 2 lines that were comments that you accidentally uncommented.
Or the comments themselves. Oh, okay.
Yeah, those need to be recommented.
Okay. Okay, now this should work, right? So now let's read our to-be text. Okay. Okay, let's run it without further ado. Let's see what we get. Okay, so we're back in business. So now we're printing. First of all, I don't need to print it this way. I could if I wanted to, but I could also just simply say, so my stack, just print the stack using the toString method. So now I print it on one line as this toString guy, wherever it is. Where is my toString? Where's my toString? Right there. The way this toString guy says it. Okay. So either way you want to do it, and now you have a nice, neat stack implementation, right? Do people see this?